Hello everyone, welcome back to another episode of Tantra's Mantra where we go behind and beyond the tech news headlines. I am Prakash Sangam, founder of Tantra Analyst and your host. So far, we have focused mainly on cellular technologies in this show. Today, we take a small detour and touch upon another important wireless technology which has almost become a lifeline for us today. I'm talking about Wi Fi here. Many years back, Wi Fi started out as a simple technology but has gotten really complex over the years and it continues to evolve. There are many spectrum bands, it started with 2.4, a couple of bands of 5 were added. Now there is 6 gigahertz, and there are many more in the planning in the future. There are new architectures such as mesh, which has become popular nowadays. Many new and advanced features introduced through Wi Fi 6 and so on. Most importantly, Wi-Fi connects extremely wide variety of devices, applications, and use cases with highly diverse performance needs, configurations, costs, and so on. Yet the expectation is that the system needs to be simple plug and play. Well, to achieve that, there are a couple of clear trends emerging. First one is managed Wi-Fi, also referred to as network as a service, and second is a pervasive use of AI, artificial intelligence, in managing and configuring these networks. Managed Wi-Fi, or NAS as it sometimes called, is simply outsourcing the complex task of configuring and managing your Wi-Fi to a third party whose bread and butter is to manage Wi-Fi, right? Nothing else. To experts, if you will, so that the users are at ease on and how their network is functioning. And on the other hand, AI ensures that the right technology, right bands, right features, right configurations are used for right devices, applications, and use cases so that you get the best possible performance all the time from your networks as well as from your devices. So, to talk all about this, we have a distinguished guest who lives and breathes Wi Fi and has been doing so for a very long time. And that is Bill McFarland, CTO of an exciting and well recognized startup called Plume. Bill, welcome to the show.
Thank you, Prakash. It's good to be on Tantra Mantra.
Thank you for coming over. Let's start with some quick introductions. Could you please briefly talk about your exemplary journey in Wi Fi as well as some background on Plume?
Sure. So we'll kind of go in reverse order. I'm the CTO at Plume.
Mm-hmm.
I joined pretty much at the beginning of the company in 2015. I lead a team that has data scientists on it,
Mm-hmm.
people who are experts in optimization,
Mm-hmm.
people who are experts in Wi-Fi algorithms,
Mm-hmm.
and then also people who know a lot about cybersecurity. And our team forms kind of the group that comes up with a lot of the algorithms that Plume uses in its systems.
Mm-hmm.
Prior to being at Plume, I got started in Wi-Fi back in 1999, really quite a long time ago, when I joined a company called Atheros Communications, which was a chip company that made Wi-Fi chips. That company went public and then eventually was acquired by Qualcomm. And I did work at Qualcomm for a number of years as well. So I have experience kind of in smaller companies and larger companies. As you mentioned, I've been in Wi-Fi for a long time. I've published over 35 technical papers in refereed journals, and I'm inventor or co-inventor of over 90 patents, kind of all in that Wi-Fi space. In fact, I was elected to be a fellow of the IEEE in 2014 for my work in Wi-Fi.
Very impressive. Glad to be here on the show and talk about all the things that are happening with Wi-Fi. So, you guys recently closed your latest round of funding for Plume, right? Congratulations on that. Can you talk a little bit about how it came about, what is its significance, and how you're planning to utilize the new funds that you've gotten?
Yeah, so it was really a bit of a surprise, actually. You know, we had raised money just 8 months earlier,
Uh huh.
and we certainly weren't in need of any more money. In working over the years, a wise VC once told me, take the money when you can get it at a good valuation.
Exactly. Yeah.
And so the opportunity arrived. It doubled Plume's valuation to $2.6 billion, and it put $300 million into our bank account. And so, you know, what it's really going to do is it's going to enable us to offer even more different services to our customers. Today, we offer Wi-Fi management, We offer a complicated system of access controls where people can give each person a different password and control what other things each device can do in the network. Well, we have a cybersecurity offering that looks for viruses and malware, parental controls, so you can monitor screen time and limit kids' access to different types of content on the web. We have Wi-Fi based motion detection, which can be used to build like a security system, a physical alarm system, but it also can be used for wellness. For example, I could tell whether my elderly parents have gotten up and eaten breakfast or not. So we'll just continue to build out more services and more sophisticated things within the services we already offer.
Excellent. Could you give us a quick overview of how this managed Wi-Fi works? I mean, it would be right to call it network as a service as well, right? I mean, how is the structure, how things work, and so on?
Yeah, well, Prakash, as you mentioned, Wi-Fi started as a pretty simple system.
Mm-hmm.
Each access point completely did its own thing, and client devices made decisions about where they wanted to connect and so forth. But it's become a lot more sophisticated as the demands on Wi-Fi have grown, in terms of the number of devices that are connecting in people's homes, the required throughput, overall system capacity requirements, and the quality of experience expectations. Virtually every device in people's homes now connects by Wi-Fi. If a service provider has a customer calling up and complaining, they don't make any distinction between whether the problem is in the Wi-Fi part of the link or the broadband part of the link or whatnot.
Mm-hmm.
And so, what this has brought about is the fact that, Wi-Fi really kind of needs to step up to the task. And that means a higher degree of management of Wi-Fi. And so it means cloud-based centralized management
Mm-hmm.
that can apply machine learning and sophisticated optimization to configure the networks for optimum performance in people's homes.
Mm-hmm.
It also means, looking beyond a single apartment, managing all the Wi-Fi in an apartment complex as a joint system, so they're not just interfering with each other and clogging the thing up. Providing cloud-based support tools and dashboards so that service providers can help their customers and see what is happening in their networks. So, kind of raising Wi-Fi up to this entirely next level. Now, one way of providing all this management and all these capabilities is through this network as a service kind of arrangement.
Mm-hmm.
And I think different people have a kind of a different definition of exactly what that means. But I think there's two key ingredients that really occur to me. The first is a notion that someone else is managing these networks for you. It just works. You don't have to know about Wi-Fi. You don't have to know, how to configure what frequency channel I should be choosing. What are all these different modes that show in the interface and so forth. There's someone else who's taking care of all that for you.
Mm-hmm.
And then I think the other aspect of that, you're paying for it kind of incrementally. You're paying for that service as you go along rather than making a big investment up front into a piece of hardware that's going to be obsolete in a few years or whatever.
Mm-hmm.
You're paying an ongoing fee, which is much smaller, but it makes sure that you're always up to date, always being taken care of, and so forth. So the bottom line, as I describe it to people, particularly as it applies into people's homes, is kind of like, what would you do to not have to deal with your kids coming to you and saying, "Hey, Dad, the Wi-Fi is not working anymore. Can you fix it?" Which for me is a problem, believe it or not. I can imagine it's really a problem for people who don't know anything about Wi-Fi. What are they supposed to do to fix it? And this is a constant hassle. So it's really about saying, you're not going to have that kind of problem anymore. It's going to be taken care of. It's just going to work. It's going to work right all the time. Someone else is taking care of all those problems for you. And for that, you do pay an ongoing fee.
That probably is one of the most asked question in the homes. What's wrong with Wi-Fi? Why is it not working? Right, especially when everybody's working home, schooling is happening home, and if Wi-Fi goes down, though, kind of the life stops during the day, right? So that I think has made people realize the importance of managing it in the right way so that there is no downtime and so on.
Yeah, there's really a lot of ways it can go wrong. And a lot of the gear that's built and sold at retail is often not, kind of constructed to the highest standards. So, there can be a lot of things that go wrong.
Exactly. But how is your go-to market model for this? Like, is it that you basically go to service providers and you provide your software to them and they sell to end customers, or are you directly selling to end customers? Or are you selling to Wi-Fi AP providers, router providers, and so on? How is the go-to market and how is the revenue being generated for you guys?
Plume does sell directly to consumers off of its website, but that's not our main line of business.
Uh huh.
Our main line of business is selling to service providers. And then the service providers resell that effectively to their customers.
Mm-hmm.
An example would be Comcast. A lot of people have seen these advertisements for Comcast XFi, which is
Mm-hmm.
kind of their Wi-Fi system. That is actually the Plume system being resold by Comcast. We have similar arrangements with Charter Spectrum, Bell Canada, Liberty Global in Europe, Vodafone, JCOM in Japan is one of our larger customers. It's a collection of both large service providers, like I've just listed, but also it's very effective for smaller service providers because it's very much a turnkey kind of product offering.
Mm-hmm.
We have more than 260 service providers signed up to offer this service. And it makes a lot of sense as a service that the service provider can offer. First off, they often can charge for this premium Wi Fi service, and that increases their ARPU, always a good thing for them.
Mm-hmm.
It can reduce the cost of support calls and truck rolls for them, so that can actually save them money.
Mm-hmm.
And then I think, most important is that it keeps their customers happy and reduces churn and so forth. Service providers, as I was describing, are really on the hook for getting the information all the way to the end device. A consumer these days, if the video is stalling on their laptop or even on their Wi-Fi connected TV or whatever, they're calling their service provider and they're not making a distinction between whether that problem is on the Wi-Fi or somewhere else within the service provider's network. The service provider is going to have to deal with that and going to have to solve that problem. So it makes a lot of sense for them to just look at the situation and say, look, let's look at this as an opportunity rather than just a burden. And let's offer Wi-Fi as a really great service. Let's manage it all the way out to the end client device. And let's treat this very professionally.
Yeah, true. So, I mean, if something happens, people don't really differentiate between, oh, it's my router problem versus, Wi-Fi problem versus backhaul problem. That's all they think is, oh, my Wi-Fi is not working. Nobody knows, what's going behind that signal that comes to the device, right? So, and obviously the service providers will be blamed no matter who's at fault there, right? So, it makes perfect sense, as you said, to convert this challenge into opportunity and make money out of it, and at the same time keep their customers happy. That's a win-win proposition for all the parties involved. And usually when people think of managed Wi-Fi, it was thought it's mostly for large buildings, enterprises, and so on. But you're saying even for simple households, users are seeing value in doing it, right? I mean, a lot of things remain the same in a home. Why do you think this is needed rather than just high level initial configuration and management? Do you think it's a big need in the homes as well?
Well, that was really one of the key visions of Plume right at the beginning was this notion that, hey, the average person in their own home, they deserve an IT department, essentially, right? But
Mm-hmm.
of course, the catch is that they can't afford to hire an IT person to look after their home. The key to this all was, the growth of artificial intelligence, machine learning, optimization, et cetera, the ability to build in the cloud kind of an automatic IT department that would automatically manage these millions and millions of homes, each one individually looking at the conditions in that home, optimizing the network for that home, et cetera, truly as if it were an individual IT department for that particular home. And the confluence of recognizing that need as Wi-Fi became more complicated and as people required a higher quality of experience from their Wi-Fi, and the opportunity that these new intelligent cloud-based technologies were going to be able to enable that. That combination is really what created the company Plume.
I like this idea of IT department or IT guy for the home who's doing it for you. I think that's kind of interesting way of putting it, and kind of puts customers who are wary of all the complex things that are happening at ease. That okay, I can rely on something who can basically look at all of these things and make sure things work and do it automatically rather than me calling or actively getting involved in it. That's, I think, is an interesting way you put it. Okay, and you mentioned about AI. I think that's a good segue to our next topic. So, can you briefly touch upon the need and the role of AI in Wi-Fi in general, and specifically in managed Wi-Fi situations?
Yeah, well, we've been talking about the fact that Wi-Fi has become a lot more complicated.
Uh huh.
A lot of homes these days actually have multiple access points in them, which is a good idea. It ensures that the entire home is covered. You don't have dead spots. And because the devices are always a little bit closer together that way, you get higher data rates,
Mm-hmm.
better throughput, and so forth. So that's all brilliant. But then you are making a lot of decisions about how that network should be configured, which access point connects to which other access point, what frequency channels are used in each of the connections, where the client devices should go, which access point in the home should they be connecting to. A lot of those same decisions are required even in homes with only a single access point.
Mm-hmm.
And so what we do is we use these artificial intelligence type algorithms in order to make all those decisions and to optimize the network in each person's home. And those artificial intelligence algorithms can be grouped into a couple categories. The first one is predictive analytics. So, for example, when we optimize a network, we often don't want to do it for the conditions that are present right at that moment. Say you're doing an optimization of the network in the middle of the night. That's nice to do because if you're going to reconfigure it, it's better not to have people using it right as you're reconfiguring it, right?
Mm-hmm.
But on the other hand, you don't want to optimize it for the load conditions and the situation that's present in the middle of the night. Nobody's using the network, right?
Exactly. Yeah.
What you really want to do is you want to predict the conditions that will occur when the peak load arrives on the network, perhaps the next day.
Yep. Okay.
And so that inherently involves looking at a past history of what's gone on in that home and what traditionally happens and what the conditions are like, and then making a prediction for the next day in terms of what those conditions are going to be like and optimizing for that set of conditions. So that's kind of
Mm-hmm.
this kind of predictive analytics class of things. We naturally do a lot in the way of optimization. And Plume is not using kind of heuristic, oh, it's usually best to attach the client to the closest access point with the strongest signal, or, arrange the AP so that it's always connected to the strongest AP, the closest AP that it can see. We are using very rigorous optimization techniques. We formulate the problem as a mixed integer linear programming problem,
Mm-hmm.
create an objective function which factors throughput to individual clients, overall system capacity, it factors fairness among clients, and so forth. We actually solve that to find the true optimal configuration of the entire network in that particular home.
Mm-hmm.
And we apply other machine learning algorithms on top of that. For example, reinforcement learning, so that we can actually tweak this and make it better and better as we learn more about that home and have more experience with that home. And then another big category where we do a lot of work is anomaly detection.
Mm-hmm.
So here we're looking for networks that are behaving oddly, misbehaving, not performing well. We also are doing anomaly detection in the area of cybersecurity. One of our major methods of detecting viruses and malware in the devices in people's home or in the networking devices in people's homes is that they begin to behave oddly. Nest thermostat stops behaving like a Nest thermostat. And this is the kind of thing that we can use these machine learning algorithms to actually come to know and detect that something has gotten out of whack. And finally, we even have quite a few backend tools that Plume supplies.
Mm-hmm.
For example, proactive network maintenance tools, where we are predicting, and part of these tools, we use machine learning algorithms to predict who is going to call in for support and what is the issue going to be. That allows you to potentially reach out to them before they even call, perhaps with an email. That saves you money, and it also can keep the customer happy. We do a lot on predicting churn, not an uncommon thing. But here we're looking at factors about the performance of people's network, factors about how they're using their networks, adding that into more traditional factors that one might put into a churn model
Mm-hmm.
and predict that customers are kind of a threat for leaving the system and going to a competitor.
I see. Okay, it's got a few things that you guys offer. So in terms of AI working itself, how is the training happening? So you're looking at the overall general trends, how things behave, and do learning from millions of customers. Take the macro learnings from them and optimize them for a specific customer or a specific implementation, or it is all local learning and implementing that local learning there. How is the meta learning versus local micro learning is my question.
So currently, all of our learning is done in the in the cloud. So
Okay.
the training and the algorithms all run in the cloud.
Uh-huh.
There are some advantages to that. So, for example, when we talked about coming to understand, hey, how does a Nest thermostat commonly behave? We can analyze that. I describe it as both vertically and horizontally. Vertically, we can analyze in this particular home,
Okay.
this particular Nest thermostat, how has it operated in the past
Mm-hmm.
and how is it operating now?
Okay.
And we can see a shift in its behavior that way, looking historically. But there's also a lot of value to looking horizontally. We're currently managing, I think, more than 35 million homes.
Mm-hmm.
We can look across the 35 million homes and find all the Nest thermostats. And we can build a model of what a Nest thermostat does, what kinds of communications it does, where it talks to, how frequently it talks, etc. And we can build a model that based on this large amount of historical data across all the different homes. And so that's one of the motivations for doing it in the cloud. You get kind of an infinite amount of compute power if you want to in the cloud. You get an infinite amount of storage, things that you really can't get on a edge device down in the home, a router or an access point, a gateway device. So that's another reason why we do it up in the cloud.
I see. So, would it be right to say that you do all the data crunching and all the computation and you come to solve the issues with settings, and then you basically dump those settings onto the access points and the devices in the night, as you said, on everyday basis to the client network? Is that at a high level how it works?
Yes, that's quite correct. And there's quite a few different elements in there. I'll talk about a few of them. Maybe we can come back to it as well.
Mm-hmm.
But one thing is that the basic philosophy that we have taken is that any function which has relatively mild latency concerns or requirements, right? You don't have to respond absolutely immediately. We try to put most of those
Mm-hmm.
functions up in the cloud so that we can apply that really great deep learning to those problems. In addition, it makes it much easier to modify the algorithms. Algorithms that are embedded in firmware, which is loaded down onto the local device to alter that algorithm, improve it, modify it, put in a new set of learning into it or whatnot. That requires doing a firmware update on the devices, and that's a cumbersome process and very much not desired very much to do frequently by the service providers.
Mm-hmm.
If you have all of those algorithms running up in the cloud, it's much simpler to update that algorithm in the cloud or to have it learn and be adjusted in the cloud. So that's our basic philosophy. Now, that said, there are some activities that go on in a Wi-Fi network that require very, very immediate response, response within milliseconds.
Mm-hmm.
Cloud response times have gotten better and better, and they're surprisingly good, actually. We still wouldn't want to depend on going all the way to the cloud, running an algorithm, and coming back with the answer for those types of things. So, for situations where a device is sending a probe and trying to get into the network, you want to respond to that and get it on the network very quickly so it doesn't wander off and connect somewhere else. When devices are moving about the house and they're roaming, they're switching from one access point in the house to another. That's another case where you want to be able to do that handoff really quickly and really efficiently.
Mm-hmm.
So, in those cases, it's kind of as you were describing. We have a set of algorithms built into the firmware that's in the device, but they're highly configurable. There's a lot of parameters that we can set about what thresholds should be used, even things about which behavior it should be. When this situation occurs, what is the action that you should take? And those configurations, those parameter settings are done from the cloud based on intelligence in the cloud, but the actual actions and activities are taken locally.
Okay.
Finally, the actual data path, the actual movement of data, whereas all the things about how is the network configured is kind of controlled from the cloud, the actual movement of data is all local. People's data does not flow to the Plume cloud. We don't see their data in our cloud. It doesn't go through any of our gateways or anything else. First off, that'd be a privacy concern, but even more, be kind of expensive for us to be handling everybody's data.
Good.
So the data continues to flow as it would even if Plume's management system is not there. It's only the management information that goes to our cloud and management control that comes back down from the cloud.
So we'll go to security in a little bit. Before that, this AI and managed Wi-Fi kind of setup, any indications on how much of performance improvement that you can achieve? Obviously, you can look at qualitatively that our customers are happy, there are less complaints and so on. But quantitatively, any measures to show the improvement that these things can achieve?
Yeah, again, maybe we can go on multiple levels on that. So
Uh-huh.
it depends a lot on what you're using as the baseline for comparison. Let's start with that. It turns out that there are some quite unintelligent Wi-Fi systems out there. If you just go to the store and you buy some kind of
Mm-hmm.
retail kit that's got, a couple access points in it and you bring it home and put it in your house, these usually aren't even very good at choosing which frequency channel has the lowest amount of interference, even when they first turn on. They don't observe how that interference changes over time, et cetera. And so connecting the APs together so that you have the right balance between the number of hops you have to go through versus how long the distances are. They usually use very simple algorithms. They just connect to the closest AP they can find, et cetera. So, and the same with client steering. Most of these systems,
Mm-hmm.
they just let the client devices attach wherever they feel like attaching. And many client devices don't have a very intelligent selection method. Most, even the more intelligent ones just say, well, I'll carefully think about, what's the strongest signal strength and for which access point should I get to. But when you think about where will the device actually get the best overall throughput, you're really looking at something where maybe you're not connecting to the closest access point. Maybe you're not connecting to the one with the strongest signal
Right.
strength. Could be that that access point is congested. It could be that that access point has a weak backhaul connection to the main network, and you'd be better off taking a longer hop immediately coming from the client, but
Correct.
connecting more into the center of the network or directly to the gateway, for example. All of the access points might have different capabilities. And you, as a client, you might have Wi-Fi 6 capability versus Wi-Fi 5 or Wi-Fi 6E with 6 gigahertz or whatever. So there's a lot of intelligence that can be applied to steering these clients around. So we do see, significant improvements in the raw performance, in terms of the throughput. We might get 3 times the throughput. When we look at overall system capacity, that can be even a bigger improvement
Mm-hmm.
because a lot of times the way these networks, if they're not intelligent, lay themselves out, there might be some kind of choke point, a constriction point in the middle of the network that now you have multiple streams of traffic that you're trying to squeeze through. And so improving that can make a huge difference in the overall system capacity in the home. And then on top of that, I think we have worked with our service provider customers, and we've seen things like significant reduction in churn, 30% reduction in churn. We've seen things like a noticeable reduction in the number of support calls and truck rolls, similar kinds of reductions of maybe 50% in support calls. And so there's, the end result, which is what the service providers really care about, is, how happy are my customers and how much does it cost me to support them. There are overall metrics in that, and I don't remember all of them offhand, I have to admit, but they are presented on our webpage, and people who are really interested can go out and see what we've actually observed in the field working with our service providers about how much these basic metrics have been improved by utilizing the Plume system.
Very well. Okay, so moving to this, privacy, user data, security, and so on. So you do have to look at people's behavior to understand and configure it right way, right? So obviously, you'll not, as you said, have access to the user specific data, what they're consuming, and so on. So how is this measuring of user behavior done then? What are the hooks that you're using to get your data that you need?
So, kind of the way the system works is that there's a software agent
Mm-hmm.
that goes down on the networking devices in people's homes. So, all the various access points and
Mm-hmm.
routers, switches, gateways, whatever. And that agent can observe what's going on. It can measure the amount of traffic that's flowing. It can measure the data rates that are being achieved on the Wi-Fi. It records and measures the amount of airtime that's being used, the amount of interference coming from neighbors, the amount of congestion that's coming from communications within your own home.
Okay.
All of that information is bundled up and moved to the cloud. And we have these reports come in on about a minute by minute basis. In some cases, it's like an alarm situation and the reports come immediately. But for
Mm-hmm.
kind of standard ongoing reporting, it comes in at about a minute by minute granularity. Now, the first thing that we do is all of that information is anonymized. So what we do is we make sure that there is nothing like a username,
Mm-hmm.
even MAC addresses of devices are scrambled in an irreversible way. So what we have in the cloud now is a bunch of information about what's going on in a particular home, but to a certain extent, we don't know who that person is. We don't know the MAC addresses of their devices or anything like that. We then do all the optimization and so forth like that. We come to the conclusions of how the network should be arranged, and we load that back down into that particular network. The data that's left over, we do use for enhancing our algorithms, doing these machine learning tasks and so forth. But that data has all been anonymized, so we can't track backwards to the individual person that is. And what's more, when we're doing that kind of analysis, we're always looking at it in an aggregated way. We're looking at, collections of users. And so you can't get to the even data set in a certain sense for an individual user becomes combined in with all the other users in a big aggregation. And so that it adds another layer of protection in terms of privacy for those.
But you said you're optimizing the network configuration and experience for specific households and devices and so on, right? So you have to have some identification to implement the changes or to understand the situation, problems that might be propping up, and so on. So there is some level of identification of the household or the customers in the analysis that you do, right?
Yeah, that's right. We have a location ID, which is a Plume. We call it the Plume location ID.
Uh-huh.
And it is true that there is a mapping. You can go through like a reverse mapping in that case to get from the location ID back to, which home is this and what email is associated with it and so forth. Because as you say, the service providers need that in order to provide support, in order to send emails about what's wrong with the network or what maybe the action the user should take, whether they should move one of the access points in their house or not and so forth. But that mapping is, held in a really kind of tight lock and key, and it's considered a valid set of information to store because there's a true business interest relationship. That's the service that the service provider is actually providing. But the point is to limit the access to that very highly. And for everyone else working at the company, working on the algorithms, whatever else, this is just a generic location ID. They have no idea who that is.
Okay. And when you think of any cloud managed network, right, versus a self-contained, locally managed network, the security profile itself is a little bit more risky, isn't it? So because you are allowing an external third party to access to the network, so isn't there a security risk a little bit more inherently in a managed Wi-Fi versus a self-contained, locally managed Wi-Fi? How are you addressing that threat, if at all?
Yeah, so I guess it depends a little bit on how you think about it. Look, all networks are connected to the internet, right? That's the whole point of them, right? Is to be able to get out
Uh-huh.
to the internet. So every network can be attacked from remote, right? And people have firewalls and things to try to prevent that. And I would say that, what Plume tries to do is to make that security even higher. A couple of things. One of which is that we use a more sophisticated firewall, and we are actually kind of looking carefully at all those firewall rules and so forth. And we can actually be updating those from the cloud. We can be learning across all these homes kind of what's going on and new threats that arise and so forth. And then beyond the firewall, which is trying to keep people out, we have these cybersecurity algorithms that look for if traffic is actually getting into the network, or equivalently, if the network is kind of reaching out in a dangerous way, going to dangerous websites or dangerous IP addresses and so forth. So we have, kind of three levels of security. You can think of it as we have traditional firewall, which we're helping to maintain and improve. We have the detection of risky connections, either inbound or outbound, which are based on IP addresses and domains and so forth. And then we have finally the detection of anomalous behavior, indicating that some device might have been infected by a virus or malware. And in the case of a device that's actually behaving anomalously, we can quarantine that device. Part of the solution that we have, that agent we put on these devices, it includes what's called a software-defined network. We happen to be using something called Open Virtual Switch, or OVS. And That's a very highly programmable and adjustable networking switch system.
Mm-hmm.
And we can use that to, for example, isolate and quarantine a device that we've decided likely has been infected by a virus or malware. So we're bringing a lot of added protections to this. In terms of the added risk of the cloud, obviously we are very careful. And I would say that securing a single cloud point is a lot easier than securing
Mm-hmm.
millions and millions of individual routers across your deployment base if you're a service provider. Detecting attacks and everything else, it's all very much more centralized. So you can kind of put a lot of wood behind the arrow of being very
Mm-hmm.
secure. And then in addition to that, just keep in mind that what's going on up in the cloud is only the management information and only the management control. So it's not like somebody can break into our cloud and thereby see anyone's traffic. Hypothetically, break into the cloud and say, oh, I'm going to put this network on a different frequency channel, right? I suppose hypothetically they
Mm-hmm.
figure that all out and try to take control of the network. But they wouldn't be able to get any of the information or traffic about what's flowing in the network. All they would see is like, well, how many bytes are flowing in the network? That they could see. And that's probably not really of a lot of value and is going to motivate someone to try to break into the Plume system.
Yeah, agreed. And also the security algorithms that you mentioned, which basically detects the anomalies from a security point of view, that I think adds many layers of sophisticated security than any individual average consumer can, bring himself, right? I think that's really key.
Yeah, and I think that again reinforces this concept that this is the kind of thing that if you were working at a big powerful company, they would have all this stuff. The IT department would have bought a whole bunch of tools and they'd be doing all this kind of stuff on their network, and that network would be heavily protected. Consumers today, if they go out and buy just a retail router, bring it home or whatever, they're not going to have any of that stuff. Again, the idea here is to bring that same level of protection that a serious enterprise would have and distribute it to individual consumers through this whole network as a service model. That's what it brings, is the ability to do that.
That's very nice. It all brings to the point you mentioned in the beginning, like being an IT guy to a home. So that's an excellent point to end our conversation for today. I think we covered a lot of ground. Thank you very much for all of the information you provided. And Plume is definitely on my radar. So best of luck with your efforts to make managed Wi-Fi mainstream.
Thanks, Prakash. It was a great conversation. Very nice to be on Tantra Mantra.
Perfect. So, folks, that's all we have for now today. Hope you found this discussion informative and useful. If you did, please hit that subscribe button down there on whatever platform you are listening this on. Again, I'll be back very soon with another episode, putting light on another interesting tech subject. Bye bye for now.